And basically, once you run them, the diagnostic statistics, the next one, okay, you have to do diagnostics, right? There are three diagnostics that you have to do when you run the system GMM. The first one, you have to test for over-identifying restrictions, right? I want to use the right words here. When you have the number of endogenous variables, and then you come up with the instruments, and the instruments are more than the number of endogenous variables, right? So normally the method of instrumental variables, for you to identify with the exact identifications, you have one endogenous, you have one instruments, enough. We call just identifications. But because we have so many instruments, we have all identifications, right? Which means you have more instruments than the number. So you have to verify whether that many instruments that you have used valid or not. And that's what we term as test of over-identifying restrictions. Why I say restriction? Because look at the moment condition. You restrict them equal to 0, all of them. And you have many restrictions that you put in. So I will over-identify your restriction, and you have to test whether that one valid or not. As a test for whether the instrument that you use are valid or not. Right? So that need to be looked at. And the test that you use normally would be Sagan test or Hansen test. My advice, Hansen test, because as long as the number of instruments is less than the number of units, you have 50 banks, you have instrument 30, Hansen test will be more robust as compared to Sagan test. Right? Because Sagan test will not be, I think, when you have two steps, sometimes you cannot perform Sagan test using XTA bond, right? But then if you use XTA bond 2, you can perform, but they are not robust if the instruments is more than the number of I think the cross-sectional units. And when you run XTA bond 2, you can read at the bottom, they say under what condition Hansen test will be better, under what conditions Sagan test will be a better one. Yeah.
It's like that.
Yeah. No, you have to read all the printout that has been given. So that's why normally Hansen test, we use them because in our implementation, we would like to restrict the instrument to be less than the number of cross-sectional units. So that's what needs to be done, right? And the second one that you have to answer is there a term correlated. So you have to run AR1, AR2 test. Right? Now, how many of you have, when you read the articles, right? Or some of you that have used the dynamic panel models, right? When you run AR1, you find that the hypothesis of no autocorrelations rejected. When you run AR2, they are not rejected. And this test implies that your error term is not autocorrelated. So what it means is that you find this one to be the case, you are safe. Right? You are safe. Anyone have problem with this? You run autocorrelation test. You have to remember the test at null hypothesis, not autocorrelated of order 1, the alternative hypothesis, autocorrelated of order 1 here, the null hypothesis, not autocorrelated of order 2, the alternative hypothesis, autocorrelated of order 2. If you find this to be the result, which means you reject this, and you do not reject this, your error term is not autocorrelated, and that's what you have to get in your estimations. Now, do you find this one as contradicting? Right? You run AR1, you reject, you run AR2, not rejecting. And then I make conclusions. With these conditions, error term is okay. No, see, one thing, because all of you are doing your PhD, your project work, for examples, right? And I'm in writing papers, you don't have to defend on this because quite standard. But then in your Viva, your examiner can be naughty, you know, can ask you, right? So you know, because I was in one Viva where I listened to the examiner. Very simple test, unit root test, right? And then in conducting unit root test ADF, examiner just asked, what criteria that you use to select the leg order in the ADF test? He never thought that type of question coming up. So he became panicked.
But I put Y, I put black one.
Unit root test. Yeah, but what criteria that you use, for example? Are you using SIC? Are you using MIC? Yeah. So those are criteria that you have to answer. But he never thought of, he just put in the computer, just use whatever default. Default is 2. Right? So which means you don't have your own choice. You just take whatever people give you. That will be a problem. The same thing here. Right? If people ask you, no, you are rejecting the autocorrelation, why you say you don't have problem? How would you answer that, for example? Right? Now, the idea is this, right? I just want to make it clear for you when you defend your work, you understand the theory behind it, right? Your model look like this, right? YIT equal to delta YIT minus 1 plus mu I plus VIT. The assumption that you make is that this error term not autocorrelated. Right? That's your assumptions, which means that VIT is not depend on VIT minus 1, or it doesn't depend on VIT minus 2. That's the assumption that you have made. Right? If you put minus 1 only, order 1, you put minus 1, minus 2, order 2. Right? So that's the assumption that you have made. Right? And when you run the test, right, remember, both first difference and system GMM, they transform this into the first difference. Become IT minus 1 equal delta YIT minus 1 minus YIT minus 2. This one filter out, you get VIT minus VIT minus 1. Let me call this one as EIT. Right? Epsilon IT is equal to this. Right? Now, when the software conducting the test, they use this. They don't use the original one. Right? They use error term. Okay? So for sure, if you run error term IT on row, error term IT minus 1, right? Remember, IT have VIT minus VIT minus 1. This one have VIT minus 1 minus VIT minus 2. When you run this on this, of course, this one will be significant because they have common term. So that's why you reject AR1. But then when you run AR2, for example, whether it depends on the error term number 2, right? For example, here, error term number 2 become I2, I3. Now there are no common term anymore. And because they are not correlated as our original assumptions, this value must be equal to 0, not rejected. So when they run autocorrelation test, they use the error term from the first difference. And that's why when we conduct the test, we should reject AR1 and we should not reject AR2. And that's basically the error term correlated or not. And the next one, you have to test, are there too many instruments? The rule of thumb, as I mentioned, the number of instruments must be less than the number of cross-sectional units. And that one really important part. You just need to test them. Okay? So the next one, the final one that I would like to discuss, what would happen? What if some X are endogenous? Right? Because I read a lot. Okay? I use GMM because GMM can address endogeneity. And they make argument that X can be endogenous, but then when they run, they never consider X endogenous. They just run using the default instata. And default instata, when you put them, X considered exogenous. But what happens if X endogenous? So you have to treat them, right, as endogenous variables. And when X endogenous, you have to understand basically two things. Reverse causality or omitted variables. Endogeneity can result from reverse causality or because of omitted variables. Okay. For examples. Okay. Okay. Now, let me give you a simple one first, and simple way to deal with endogeneity. And the rest, maybe Sulaiman have my book. You can distribute to everyone, soft copy, and try to take a look at that book, and also the codes of how to estimate all in that book. Very easy to go through and just replicate. Right? Now, one study that has been done, for example, that look at, let's say, NPLs, IT, and you want to look at whether loans affects credit risk or not. So you get beta 0 plus beta 1 and you get lending, IT, and so on, right? Or you can put beta 2, bank size, IT, right? Now, remember the basic assumption that we have made, and you have dynamics terms, delta, NPL, IT minus 1, and so on. Now, remember the basic assumption that we make is that the X that we include, they all are exogenous. But then if someone asks you, no, you write in this way, and someone asks you, no, someone said, lending is endogenous. Why? Because there exists reverse causality. Yes, lending may affect the riskiness of bank and non-performing loans, but we also know that non-performing loan can affect the strategy of bank to lend. When you have high non-performing loan, you tend to limit lending. So lending becomes your dependent variables. Right? So it means that lending is endogenous because of that reverse causality. Now, how to deal with that problems? Right? Now, if you look at many studies that has been done on the bank level or the firm level, for examples. Right? Not so much on the country level, but on the bank level, on the firm levels. One thing you pay attention in terms of model specifications. In order to resolve or mitigate that problem of reverse causality, instead of using T, they use T minus 1. By arguments that something in the future will not affect something in the past. So there should be no reverse causality. That's one way people deal with it. Right? But then if you want to deal with it, acceptables, but then if you do not want to deal with this, then you have to address this in GMM estimations by treating lending as endogenous variables. Which means that when you write your codes, in that GMM bracket there, not only you put lag dependent variable, but you have to put other endogenous variable too. The issues coming up would be the instrument would be a lot. Because now you have instruments for the lag dependent variable and you have instrument for the new endogenous variable that you introduce. Right? But that's a way to address the instruments. As I mentioned, the most simple way that most people use by using lag 1. Right? By using lag 1. The other parts that people make arguments here, for examples, you use this. Right? And people will ask again that, no, because of the endogeneity coming up, these two are related, right? They are related between these two, this cause this, and this may be related to error term because you omit one variable out. Let's say you omit capitals of the bank, and when you omit this one, this term you go to the error term. But if this capital correlated with this, it makes this one to be correlated with the error term. So you have omitted variable source of endogeneity. These are more difficult to address, but then you can mitigate the problem. Right? Now, have you seen in any published article, the good published article in good journal? Look at the table of result, the first table. Have you ever seen that they just report one equation or they report many equations that they estimate? Right? Normally, they report many equations. And normally, the difference in many equations that they report is the number of independent variables. Right? They put 1 first, and they put 4, and they put 6, they put 10, and they put all of them together, for examples. Why? Because they want to look at, by adding more and more, as a way of something you are not so sure to put in or not to put in the X.
You can do that?
Yes.
I thought that's why informal way.
Yeah, no, but it's not informal ways. Let's say.
That's legal way.
Yeah. Let's say in your case, for example, right? In terms of your case, for example, right? You do this. Your economic growth is YIT. You have lag dependent variable YIT minus 1, and you have beta 1, your multilateral debts, for example, right? And you have your key, beta 2, you use saving, right? And then you have beta 3, you have labor, right? You have labor in there. And this is your very, very basic model that you use. So in your first equation, for example, you can include YIT minus 1, MD, and then you can include saving, and you can include labor. But in second equation, you can include all 4, but you can add no. For example, you can add other macro variable. In equation 3, you can add other variable, and you can add governance indicators, for example. So you can add more and more. The reason, not because you are interested in this. You are not interested, but these are the variables that has been considered in the past that you do not want to omit them. Your interest, while you run all these things, you want to see whether this one remain the same or not in terms of significance and magnitude when we add more and more. Right? So which means that as we try to resolve the problem of some variable being omitted, whether my key result remain the same or not. Because the argument people will ask you, right? Why you just estimate? I ask you, why you just use these two? I ask you, there are government spending, there are trades, there are finance.
Like I said, the Harris government one, they
Yeah.
try to do that, but then the second one, the solo one, they try to add technology.
And
That's why I put
yeah, and people make argument, for examples, Harut Duma is not the right model, right theory. Now we have the better theory. So why you omit all these things? So that's why you have to consider some other control variable. The purpose not to check whether these are important or not. The purpose is to check whether your conclusion remain the same or not regarding your first objective, regarding your main objective. If these remain the same, we call robust finding. If these not remain the same, you have to be brave to say that your finding is fragile, depends on the way you include the independent variables. Now, so these are the way that we look at it in order to solve the problem or mitigate the problem of omitted variable bias. Okay? So that's why I think if you read article and all of you are required to publish and so on, pay attention not to the writing, the content, but also the way that they put in tables, how they put in strategy, the way they present the variable. In that way, you can learn more. Why people do the way they do. Because the reasons, all article must convince the readers that the findings are valid. And the way that you do things must leave a small room for people to ask. If you just do one equations, there will thousands of question people ask. Right? But if you do this, why not you adding the governance indicator? Because a lot of studies have said governance indicators are important. I have done my robustness checks. I am not including governance indicators, but my finding remain the same. Now see, you consider. See? And some may ask, why just you use GMM? No, I have considered GMM, but then I also consider some other estimators that are viable to be used, and result remain the same. Again, you are covered up in terms of your findings.
Sometimes we do that informally in Starlight. We try out but we didn't acknowledge it in the actual.
No, at least, for example, if you do a lot of things, you might not want to report everything because of it can be text and so on. You put in footnotes. We also conduct this, result remain more or less the same, for example. Right? So, and sometimes we put, we have conducted this in addition to the baseline, and result more or less the same, and the results are available upon request, for example. In the article, normally people put that. So there's a way of covering yourself up that you have considered all angles, right? So chromatic analysis have to be done in that way, in a serious way, careful, so that at the end your result will be good, right? And those are things regarding GMM. And my apology now, the theory alone 2 hours, because normally when I conduct the workshops, the title workshop, Dynamic Panel in 4 hours.